We're continuing on with 6A. We've got a couple of systems of equations that they've asked us to solve by graphing. Remember that solving them will be coming up with the ordered pair or pairs that actually make each one of these individual linear equations a true statement. So we're going to solve it by graphing, which means they want us to graph the two lines, find the point that it intersects, and then prove that that ordered pair works. So just ignore my graphs for a minute. I tried to see if I could possibly draw straight lines while I wasn't under pressure talking to y'all, but it didn't work. So the first thing we're going to do is put these in slope-intercept form so that we can quickly graph them. So x minus 2y equals minus 2. This is good practice. In doing this, we're going to subtract x from both sides. We're going to divide each term by minus 2. And we get y equals, and that's going to be 1/2 x, and the 1/2 is going to be positive, and that's going to be plus 1. So we've got our slope, and we've got our y-intercept. So if you go over here, and you can see where I graphed it, I started at 1 on the y-axis. I went over 1, up 1 over 2, up 1 over 2, up 1 over 2. So that's the blue line. The second one, I graphed in green, x plus y equals 4. That's a little bit simpler. We'll just move the x over, minus x plus 4. And our slope is the ghostly -1. And our y-intercept is 4. And I graphed that one in green. I started at 4. My slope is negative, so my line is going to fall from left to right. And I simply went over 1, up 1, falling left to right. So when you guys are doing these, I cannot stress how important it is that you have a good straight edge, because you can look at the mess I've got, and it's going to be really hard to see accurately where they intersect if you don't have a graph that's drawn well. So they do intersect at this point, and we can sort of see it on my graph. So the ordered pair that we think is the solution to this system of equations is the ordered pair 2, 2, but we've got to prove it. So we've got to plug it in both of our equations and say 2, is that really equal, that's a question mark, to 1/2 times 2 plus 1. So half of 2 is 1 plus another 1. Yep, it works just fine in that equation. This one, when we plug it in, 2, is that really equal to minus 2 plus, no, minus, wait. 2 and 2, so minus 2 plus 4. Yeah, it is. Thought I had a double negative there. So 2 is equal to 2, and again, we've proved that the ordered pair 2, 2 is the solution of this system of equations. So we've got another pair down here. We can go ahead and put them in the y-intercept form again. X plus y equals 0, or y is equal to minus x plus 0. So we know this guy is going to go through the origin, and his slope is -1. So if we do that, you can see I did this in red. I started at 0, went up 1 over 1, up 1 over 1, up 1 over 1. So this is my graph in red. I'll do a red line. And then the blue graph, x minus y equals 4, minus y equals minus x plus 4. Or positive y is equal to positive x minus 4. Our slope is 1. Our y-intercept is -4, and I've gone ahead and graphed it. Down here, starting at -4, the slope is positive, up 1 over 1, up 1 over 1, all along the way. And they do have an intersecting point, and there it is. It's 2, -2. So I'm thinking that that's the solution, but I have to prove it. I've got to plug him in. So I'm going to plug him in over here. Minus 2. Does that really equal to minus 1 times positive 2 plus 0? So, yep, that one works. And we go back over here to x minus y equals 4. When you plug it in, plus 2. X is plus 2 minus a minus 2 equals 4. So 2 plus 2, does that equal 4? I knew I had a double negative in here somewhere. I just couldn't remember which problem it was. Yes, that's a solution. So let's go on to the next page. I want to point out the next example. So here's one. There again, they're asking us to solve by graphing, and this looks like any other thing that we've done before. So I'm going to come over here with the first one, 2x minus y equals 1, and I'm going to start setting it up in the slope-intercept form. So minus y equals minus 2x plus 1, or positive y equals positive 2x minus 1. So that looks pretty good, and now I'll go set up the second one, which is 2x minus y equals 5. And again, we'll subtract 2x from both sides, minus 2x plus 5. And to get y positive, we make it 2x minus 5. Now, you may or may not notice this right off the bat, but these guys have the exact same slope. So if you remember from Unit 5, two lines that have the same slope are parallel. So these guys should not intersect ever. They should run like railroad tracks right next to each other forever and ever, but they should have no point in common that makes a solution. So if we want to go and solve it graphically, because they told us to, let's start with the first line over here. We'll go, we'll start at -1, and we'll go up 2 over 1, up 2 over 1, up 2 over 1, and I'll go down 2 over 1, down 2 over 1, and I'm going to try to get through that one. And then the second one, we're starting at -5. So that's down here. But the same slope. Up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. I think I might have plotted this wrong. This is looking like they're too close together. But when you guys do it on your own, let's see. I think I got just a little too close together. There it is. It's that one. Up 2 over 1. There they are. So when you guys plot these on your own and you get a good straight edge, you're going to see that they do run parallel. So they, where do the two lines intersect? They don't intersect. They don't. They are parallel. Thanks for watching.